Thank you very much, and thanks for having me back here in this in these hallowed halls for the second time in front of this dazzling audience. Well, I'm dazzled by some of you anyway. I'm not much of a statistician, so I won't be putting up any matrices or anything like that. I had to write down something from Ian's presentation earlier. I don't think I'm doing any technology de-risking, but maybe I am sort of implicitly, but I'm fairly sure I do have a client for this so-called rapid bioassay. The right partner with ALS in this case is HydroQual Labs here in Calgary. So Liz Henson and Brian Shaw are my collaborators in this work. They did earthworm testing to go along with the rapid bioassay. And the rapid bioassay is in fact the Microtox test, which of course is normally a method for contaminated water. So we've tried to turn it into a rapid test for contaminated soil. The reason why you might want to do that is because of the Tier 2 document that's been referred to already today, under which, well, the idea is that you're making a claim that PHC contamination at your site it happened so long ago that plants are starting to grow there, that probably other biota are happy there in that soil, even though you're still failing to meet Tier 1 criteria. When you do a solvent extraction, the petroleum hydrocarbon levels are above Tier 1. So you're trying to appeal to Alberta Environment to ease these Tier 1 thresholds up to some Tier 2 value, which you hope will be above the level that is currently at your site. Now that involves a lot of heavy lifting under the weight of evidence approach, because you have to do a lot of bioassays in the battery of bioassays that are specified by the CCME, and it takes months and months, and I think this $10,000 cost per site is maybe low by a factor of 2. So the Microtox test, if you could get it to work with soil, is an attractive alternative. It uses this luminescent organism, marine bacterium called Vibrio fischeri. So you put little aliquots of this into, usually the way we do it anyway at ALS and most other labs, you put aliquots in 5 of these little cuvettes which go in the wells in row B, set up a series of dilutions of the test solution in row A, including a control here in the first column, and then transfer into row B and measure the light output. So in the increased sensitivity assay, which was developed here in Vegreville by Irene Gaudet and Ansar Qureshi, you test these 4 concentrations, and you put each of those cuvettes one at a time into the read well, press the read button here and take the reading, and if you get a reading as low as that, you know you're dealing with something very toxic, because you start out around 95 rather than 5. It's a very rapid bioassay. The idea here, and I have to show you this graph to indicate how you arrive at the so-called EC50. That's the concentration at which the light output is now 1/2 of where you started. So you plot the light readings from each of these four points on a graph of concentration against what I sometimes call the light loss ratio, and I sometimes call it by the old-fashioned letter gamma. It means the same thing. Anyway, this soil, if it were a drilling waste extract, it would be a fail, because you can see that where the line crosses the vertical axis, where gamma is 1, it's around 20%, 40%, whereas the pass threshold in Directive 50 is 75%, so this would be an outright fail. Enter the cyclodextrin molecule, and I have to give Miles Tyndall and indirectly Gladys Stevenson credit for telling me about this molecule a number of years ago now. Cyclodextrin comes in alpha, beta and gamma forms, and this gamma form has 8 of these glucopyranose rings arranged in a sort of cylindrical structure, and there's a hole in the middle of this molecule, and that is capable of interacting with, or PHC molecule can either climb in there or get partly in there and form an association complex with the cyclodextrin. So you can make a normally non-water soluble molecule of PHC soluble by complexing it with aqueous cyclodextrin, and all these OH groups, and you put hydroxypropanol groups on the outside to make the cyclodextrin very water soluble. And it seems from various studies that cyclodextrin extraction pulls out only a small fraction of the total PHC which a solvent like dichloromethane or hexane acetone would pull out. And Miles was able to show that there is a correlation between CD extractable PHC and earthworm bioassay data. So that study was published, good heavens, it's coming up to 8 years ago. And the results of that study suggest and back up what the people at the University of Lancaster in the UK found, Reed et al., working with polyaromatic hydrocarbons. They came to the same conclusion. And this has been the potential of cyclodextrin extraction for indicating bioavailable hydrocarbon has been mentioned in the CCME document, but so far no one's come up with threshold values. And it's taken me all this time to get this idea to work, that if you could make get a cyclodextrin extract and make it toxic in the Microtox bioassay, then that might be a useful screening test for indicating site toxicity. The idea is to make these 4 data points that we were just looking at cross this axis where the light loss ratio is 1. But what you find with an untreated cyclodextrin extract, even if you've got 5,000 parts per million of hydrocarbon in there, all the data points line up. There's no relationship between concentration and toxicity. So what we're aiming for is somehow to break that cyclodextrin molecule apart, release the hounds, as it were, so that the petroleum hydrocarbon will be toxic in the Microtox bioassay, and you'll get a line that slopes and crosses the LLR equals 1 line. So here are the ingredients that you need in order to make this to work. The gamma cyclodextrin, make an aqueous solution of that, and shake your oil contaminated soil with that cyclodextrin solution for about half an hour, centrifuge, and then test the pail centrifugate. After you've activated it using some of this stuff, which is amylase enzyme. So amylase, it seems, is capable of breaking the cyclodextrin molecule apart. It kind of makes sense because cyclodextrin is made by the enzyme reaction with starch. So, you know, different enzyme can take the structure apart again. Kind of makes sense. So you also need the Microtox apparatus, the Model 500, but here you've got the all the materials you need to get a graph like that and get a toxic reaction. Now, I was under real pressure about 6 weeks ago with a completely different deadline, so that I gave myself, what's the term, a displacement activity to put more pressure on myself to meet this other deadline. And I thought up this little experiment in which the soil on the left here has been spiked with PHC. Now in Directive 50, one of the diagnostic little tests you can do to see if the toxicity is due to hydrocarbons is you can treat the extract with charcoal granules. So that's what's been done in this middle tube here. And then in the third tube, I just screened those out at the end of a two-week period at room temperature. A soil on the left is has been spiked with PHC, left for 2 weeks. The one in the middle, the charcoal granules have been left in it, and the one on the right, the charcoal granules have been screened out before doing the Microtox bioassay. And what happens with the one on the left is you get a very, very toxic reaction. You can see the intercept here is down somewhere near 10%, so that's very toxic. And the middle one, all the points have moved across to the left, as you'd expect. The charcoal granules have taken out the toxicity. And where I've removed the charcoal granules, those points are also almost in a straight line. No toxicity there. So, I mean, this sort of reinforces our thinking, or my thinking. The crucial thing is the one in the middle. I've left the charcoal granules in there and I've shaken that mixture with cyclodextrin solution. So you can imagine if the soil was high in organic matter or some other sequestering agent which took out the PHC, you would not want cyclodextrin to come along and recover it again. And it seems that it doesn't. The cyclodextrin is doing the right thing. It can't pull those sorbed hydrocarbons off the charcoal granules. So things are behaving sort of the way they should. As has often been observed, you know, toxicity increases as the EC50 or IC50 goes down. So people sometimes do the inverse and come up with toxicity units or a toxicity index, which is just 100 divided by the EC50. So that's what is plotted here. Toxicity index against spiked petroleum hydrocarbon added to a soil, the same soil we were just looking at, in fact. So you can see there's in this case, a linear dependence with a very good correlation coefficient. So this is the soil that's been spiked with different levels of PHC, and the toxicity is increasing in keeping with the level of PHC. And we use diesel fuel, which is almost entirely F2 and F3 as a source of PHC, and we managed to sneak that past the reviewers at CamJ Soil Sci last year. So it's just a note, you know, it's just a kind of a proof of concept article, and if anyone's interested, I can provide you with copies of that. But it's not the 64,000 question, but we're getting 50,000 out of PTAC, and thanks to PTAC for sponsoring this work. to see if earthworms in the soils behave in a way that matches the way the cyclodextrin extract behaves towards the Microtox bioassay. And looking back at that previous graph, 100 over 50 is around 2 toxicity units, and that corresponded to around 1,000 parts per million of F2, F3. So that's in line with CCME criteria for freshly applied PHC. So maybe a soil that gave a CD extract with a toxicity index greater than 2 would give earthworms trouble. We got some soils courtesy of various Alberta mainly drilling waste disposal contractors. One of them was Noralta, and they provided a soil that was really very low in PHC, and the toxicity index using the cyclodextrin extraction Microtox test was 0.4. So you wouldn't expect to see earthworms having any trouble, and HydroQual's data indicate that. So even at they thought we were using the 90.9 Microtox test, so they matched those concentrations by diluting the soil with some artificial soil. But they needn't have done that, but it doesn't matter. In essentially the pure Noralta soil, there's just as many earthworms surviving. There does seem to be, even in that soil though, a little trouble with, like the plain bar graph is the juvenile, the 7-8 week, or is it 8 to 9 week juvenile production. So even in that soil, there's maybe a little chronic toxicity. In this other soil, which by contrast is quite loaded with PHC, our rapid bioassay toxicity index was 2.5, so we're expecting to see some trouble here, and sure enough, at the highest test level, the earthworms just aren't able to survive. So there does seem to be some kind of a correlation here between this 2-hour Microtox cyclodextrin bioassay and the earthworm bioassays. So the conclusions or the rationale from this would be that gamma cyclodextrin extracts of soil with PHC after amylase treatment are toxic, and that toxicity is related to PHC in the soil. So if I didn't say it already, we're not thinking of replacing any of the battery of CCME bioassays, because then Gladys would be out of work. What we're doing is thinking of using it as a screening test to indicate whether earthworms can even survive in your Tier 2 candidate soil. If it fails this rapid bioassay, we're suggesting don't even bother going through the the earthworm and all the other battery of tests. It'll cost you a lot of money, and it will fail. And that's the project number, so you can get that report, I'm sure, from PTEC. I'm putting Lord Kitchener up here, pointing in a threatening manner. Your country needed you a long time ago, but what HydroQual and I, and now Stantec, I'm glad that Gladys Stevenson, Stantec, is also involved with the next phase of the project. What we need from you are Tier 2 candidate soils, and what you'll get in exchange for your Tier 2 candidate soils are, you'll get from ALS, you'll get all the hexane extractable PHC data. You'll get the earthworm reproduction bioassay data from Stantec and HydroQual. We'll give you some information about how the earthworm data are correlating with the cyclodextrin bioassay and other project information and the overall conclusions. So I'm pleased to put Stantec's logo up there. We're very encouraged at the funding we've received for phase 3. So if you know of, or if you have any tier 2 candidate soils, please let me or Gladys or Liz Henson at HydroQual know about them.